students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we'll be doing this chapter called as network analysis. Let's see the sum. I'm doing question number 1 on page 363. I'm writing the question down. Activity A, B, C, D, E, F, G. Preceding activity. Nothing, A, B and C, D and E. Here they've given you 3 different types of time in days. They've given you the optimistic time, most likely time and pessimistic time. Right, 2, 5, 8, then 2, 5, 14, then 4, 6, 14, then 5, 7, 15, then 2, 3, 10, then 3, 3, 3, and 1, 2, 3. This is the data that's given to you, right? Now what have they asked you to find out? They've asked you to draw a PERT network. First part of the question is draw PERT network. Now what do I understand by PERT network? Now we've already learned what is network analysis. What do you mean by PERT? PERT stands for Program Evaluation and Review Technique. Program Evaluation and Review Technique. Okay. Now, so first let's see the first part. I'll go on writing each part of the question and I'll go on completing that, and then I'll move on to the next part of the question. For that, first of all, you need to draw a diagram. Let's see, how do I get this diagram? How do I get time? Because they've given you 3 different times. How do I find out which time should I consider? Right, for that you will have to draw this table, timetable. First thing, you have activity A, B, C, D, E, F, G. Right? Now you have to find out expected time. How do I find out expected time? Expected time is given by the formula TE is A plus 4M plus B upon 6, where A stands for optimistic time, M stands for most likely time, and B stands for pessimistic time. Right? So in this case, for activity A, it will be 2 plus 4 into 5 plus 8 upon 6, 20 plus.
So why 6?
That's the formula, right? So 20, 28, 30. 30 divided by 6, that is 5 days. For activity B, it will be 2 plus 5, 4 into 5 plus 14 divided by 6. So this is going to be 20, 34, 36 divided by 6, that is 6. For activity C, it is going to be 4 plus 5 into 6, 4 into 6 plus 14 divided by 6, 24, 34, 38, 42. 42 divided by 6, that is 7. For activity D, it is going to be 5 plus 4 into 7 plus 15 divided by 6. 7 4s are 28, 38, 39, 40, 43, 43 plus 5, 48, 48 divided by 6. 6 8s are 48. For activity E, it is going to be 2 plus 4 into 3 plus 10 divided by 6. Right, 4 3s are 12, 22, 24. 6 4s are 24. For activity F, it is going to be 3 plus 4 into 3 plus 3 upon 6 12 plus 6, 18. 18 divided by 6, 3. For activity G, it is going to be 1 plus 4 into 2 plus 3 divided by 6, 8, 9, 12 divided by 6, 2. That's how you get your expected time. Fine. Optimistic time is represented, guys. If you want, I'll write this representation here. Optimistic time is represented as A, most likely time is represented as M, and pessimistic time is represented as B. So that's how I got the different timing, right? Once you get the expected time, the next thing that you need to find out is variance. The next thing you need to find out is variance. How do I find out variance? Variance is given by the formula B minus A, the whole square, upon 36. Why do I need variance? Just wait for some time. I'll show you where do I and why I need a variance. Let's just calculate first. Once I draw the diagram, I'll be able to explain to you. B minus A. So this is 8 minus 2, the whole square upon 36. 8 minus 2, that is 6. 6 square, that is going to be 36 upon 36. I'm not dividing this. Reason why I'm not dividing, because later I need to add. Later somewhere in the sum I need to add. That way I have a common denominator. That's the reason why I'm not dividing. So I'm just going to find out the numerators and keep them as it is. For activity B, it is going to be 14 minus 2 upon 36. 14 minus 2 the whole square. 12 square is 144 upon 36. Then you have for activity C, it is 14 minus 4 the whole square upon 36. 10 square, 100 upon 36, right? For activity D, it is going to be 15 minus 5 the whole square upon 36. 10 square, 100 upon 36. For activity E, it is going to be 10 minus 2 the whole square upon 36. 8, 64 upon 36. Then for activity F, it is going to be 3 minus 3 the whole square upon 36. That's 0 upon 36. And last for activity G, it is going to be 3 minus 1 the whole square upon 36. 2 square is 4 upon 36. Fine. Once you have this, then once you have the timetable, then you draw your network diagram. So the first thing that you have to do is, when you are doing PERT analysis, you draw your timetable. Then you draw your network diagram, right? Let's start from activity A. So you have event 1. Nothing precedes A, nothing precedes B. So from event 1, you're going to have activity A and activity B. What time will I consider? I will consider the expected time. The expected time of activity A is 5 days and the expected time of activity B is 6 days. A goes to C, 2, 3, right? Now, A goes to C and A also goes to D. A goes to C and then B and C combine. So that means this has to be C. C is expected time is 7 days, right? And A also goes to D. A also goes to D, which has 8 days, right? B and C combine to give you E. B and C combine to give you E. E is 4 days, right? This is 4 and this is 5, right? D goes to F. D goes to F, which is 3 days, and E goes to G, which is 2 days. So this is my 6. That will be my network diagram. Simple, straightforward network diagram. Once I have the network diagram, let us find out the various paths that I have. One of the path I have is ADF. Then I have a path ACEG. Then I have a path BEG. So these are the three paths that I have. Duration. ADF is going to be 5 plus 8 plus 3, 11 plus 5, 16 days. This is going to be 5 plus 7 plus 4 plus 2, right? So this is going to be nothing but 18 days. And this is 6 plus 4 plus 2, 12 days. Right, this is 12 days. So in that case, my critical path is going to be ACEG and my expected project completion time is going to be 18 days. Right? So I will have critical path is ACEG and project completion time is 18 days. Right? So the first part of the question is done. Draw PERT network. So we've drawn a PERT network. Next, the second part of the question. The second part of the question says that what is the probability that the project will be completed in 18 days. Second part of the question, 21 days. Third part of the question, 16 days. Right? First part of the question was draw network analysis or draw a PERT network. Now they've asked you probability. Now, before I start with the probability, I need to find out my variance of critical path. Whenever they say probability, let us first find out variance of critical path. My critical path is ACEG. The variance for A is 36 upon 36. C is 100 upon 36. E is 64 upon 36. And G is 4 upon 36. Now the reason why I didn't do cancellation when I was making the timetable is because I wanted 36 as my common denominator. I can take 36 as my common denominator. This is 204 upon 36. 204 upon 36 I presume is 5.67. So my variance of critical path is 5.67 days. Once you get variance, then you can find out standard deviation. Standard deviation is given by the formula square root of variance. So this is going to be square root of 5.67 days, which will come to 2.38 days. Right? Question. Sir, why are you finding out the variance and why are you finding out the standard deviation? The entire data that is given to you can be represented for probability in the form of a diagram. That particular diagram which represents the entire data for probability purpose is called as the bell curve. So whenever they ask you probability, you have to draw a bell curve. First I'll explain to you how a bell curve looks like. As the name suggests, the bell curve looks exactly like one. Okay, this center line is going to be TE, right? The bell curve is divided into two identical halves. Each half occupies 50% of the total space. Each half occupies 50% of the total space. This curve is also called as bell curve, or it is called as the normal curve. Fine, do we get this thing here? Where you have time on x-axis and probability on y-axis. It's a curve that represents time versus probability. Fine, do we get this thing clear? The central time, that means here it will start from 0. The center line is going to be 50% and this point here is going to be 100%. Fine, do we get this thing clear? The central line also indicates the project completion time. The central line indicates the project completion time. Fine, do we get this thing clear? Okay. Let's start. Now that we have understood what the bell curve is, let's see the first part of the question. First part of the question is, what is the probability that the project will be completed in 18 days? Project completed in 18 days. Right? Now 18 days, as I already told you, is the central line, and the central line indicates 50%. This is 0, central line is 50 and the other end is 100%. So what is the probability that the project will be completed in 18 days? So probability of 18 days is going to be 50%, because that's my central line, right? TE, this is my project completion time. This is 18 days. This line represents my 18 days line. And this line also indicates 50%. 50% means 50 upon 100, so that is 0.5. So probability that the project will be completed in 18 days is 0.5. That's my probability that I'll be able to complete the project in 18 days. Fine, do we get this thing here? Second part of the question. What is the probability that the project is completed in 21 days? Right? Now, since 18 days is 50%, I want to find out what is the percentage for 21 days. For that, I have to find out a variable Z. Z is called as a normal variable. What do you mean by normal variable? A variable that will be shown on this normal curve. The variable which will be shown on the normal curve is called as your normal variable. How do I find out the normal variable Z? Z is given by the formula due date minus expected project completion date. Project completion date divided by standard deviation. Right? So someone wanted to know, sir, why did you find out the variance and standard deviation? Because I need the standard deviation here. Right? Due date. In how many days I want the project to be completed? In 21 days. What is my expected project completion days? 18 days. What is the standard deviation of the project? Standard deviation you found out is 2.38. Right? 2.38 will give you 1.26. When you subtract and divide this, 21 minus 18 divided by 2.38 will give you 1.26. Right? Once you have this, so I know my value of Z. Let's draw the bell curve for this. The bell curve for this is going to be this. I know is 18 days. This is my bell curve, right? I want 21 days. I know that 21 days will be ahead of 18 days. Let us assume that 21 days is somewhere here. This is 21 days, right? Now what is my normal variable for 21 days? You just found out that the normal variable for 21 days is 1.26. We also know that the bell curve is divided into two identical halves. The area of each half is 0.5. So the area of the previous half, the first 50%, will be 0.5. I want to find out this area, for which they've given you a table on page number, in some books it's on page 404, in some books it's on page 433, the normal probability table. Right? Everyone's got your normal probability table. I want 1.26. To the extreme left, see 1.2. And in that particular row, go up till 6. So you will get this as 0.3962, 1.26. Right? Everyone's got that? 1.26. Right? It comes to 1.26, 0.3962. So this area is 0.3962, right? The probability that the project will be completed in 18 days is 0.5. I want 21 days. So what is the probability of 21 days? Probability of 21 days will be my entire this shaded portion. So which is going to be nothing but 0.5 plus 0.3962, which is 0.8962. So the probability that the project will be completed in 21 days is nothing but, convert this into percentage. To convert into percentage, multiply by 100, 89.62%. So there are 89.62% chances that the project will be completed in 21 days. Third part of the question. What is the probability that the project will be completed in 16 days? Very simple, guys. First, let's find out the normal variable, right? Normal variable is due date minus project completion date upon standard deviation. I want the project to be completed in 16 days. My normal expected project completion date is 18 days. Standard deviation is 2.38. So this is going to be minus 2 upon 2.38, which will come to minus 0.84. Look at your probability table. Before that, let me just draw the bell curve. The central line is 18 days. This is my bell curve. 16 days is going to be before 18 days. If this is 18 days, starting from 0, 16 days would be somewhere here. I want the project to be completed in 16 days. I want the project to be completed in this shaded area. Now we know that, guys, we know that the area from 0 to 18 days is 0.5. Right? Do we get this in clear? Now for 0.84, someone please check and tell me how much is for 0.84. For 0.84, 0.2996, it's 0.2996. 0. This area is 0.2996, right? In that case, what will be the area of the shaded portion? The area of shaded portion is going to be nothing but 0.5 minus 0.2996. Whole area minus this area will give you the area of the shaded portion. Basic geometry, guys. This comes to 0.2004. So the probability that the project will be completed in 16 days is 0.2004. Convert this into percentage. To convert this into percentage, I need to multiply by 100. So 20.04%. So there are 20.04% chances that the project will be completed in 16 days. Right? Now let's see something else in this, the third part of the question. Now the third part of the question says that the project manager wants an assurance of 95% that the project will be completed in time, right? Assurance The project manager wants an assurance of 95% that project completed on time. Right? Now so far we were calculating the percentage that what is the percentage that a project would be completed in n number of days. Here they have given you the percentage and they have asked you to find out in what is the in how many days, that is in how many days will it require for 95% probability that the project is going to be completed. Now when I want that particular assurance, first let's draw the bell curve and understand this, guys. Bell curve, we know that the area from 0 to the central line is 0.5. If I am saying 95%, probability is given to you as 95%. 95% means 0.95. 95% means 0.95, out of which 0.5 area I have here. That means how much more area do I need? I need an area of 0.45 more, because 0.5 plus 0.45 will give you 0.95, right? That means on the right hand side of the bell curve, I need an area of 0.45. Fine. If we get this thing clear, that means this shaded area. How will I get this shaded area? Shaded area, I'll give you in terms of formula also. Shaded area is going to be 0.95 minus 0.5. That's 0.45. Once I know this, that means my my normal variable is 0.45, right? Now, let's look at the probability table and find out the value closest to 0.45. 0.45. The closest value I can get is 0.4505. Please look at your normal probability table. The closest value that I can get to 0.45 is 0.4505, which is nothing but 1.65, right? For area, I can say that for area 0.45, Z is 1 point, we just found out how much is it? The closest value is 0.4505, 1.65. So Z is going to be nothing but 1.65. Everyone's followed how I got that 1.65, right? I want area of 0.45. What is the closest? I may not get the exact value. I'm finding the closest value to 0.45. The closest value to 0.45 is 0.4505, for which my my normal variable is 1.65. Once I know my normal variable, we know that normal variable is given by the formula due date minus expected project completion date upon standard deviation. 1.65 due date we don't know, project completion date is 18, upon standard deviation is 2.38. Cross multiply 1.65 into 2.38 is due date minus 18. Multiply this will give you 3.93 plus 18. Minus 18 goes on the other side, becomes plus 18 is due date. That means my due date is going to be 21.93 days. %, chances that the project will be completed in 21.93 days. My expected date is 18 days. My expected project completion time is 18 days. How much more time do I require beyond that? Right? I can say that the extra number of days required is 21.93 minus 18, 3.93 days, which is approximately equal to 4 days, right? To have 95% assurance that my project will be completed in time, I need 4 days more. So if I'm a project manager and I want the project, I want 95% assurance that the project will be completed on time, what should I do? If I start my project 4 days early, instead of starting the project on whatever date I was going to start, if I start my project 4 days early, then there will be 95% assurance that in the next 18 days I will be able to complete my project in time, right? So in that case, hence, by starting the project four days before the original starting date, before the original starting date, there is 95% assurance that the project will be completed on time. Right? Do we understand this? This finishes the sum. We'll stop this here for the day. Thank you very much.